If the wind pushes you east, but you are walking north, then where do you actually go? It's not east, it's not north, it's something new. That's the magic of the resultant vector. A resultant vector is the single vector that shows the combined effect of two or more vectors acting together. So when multiple forces, velocities, or displacements act at the same time, they don't fight, they combine. If two forces pull in different directions, the object moves in a completely new direction, determined by the resultant vector. And yes, it has both magnitude and direction. When two vectors A and B make an angle theta between them, the resultant is r equals the square root of a squared plus b squared plus 2ab cosine theta. Now you know the secret behind net force and motion. Subscribe for more mind-blowing physics. Do you know what is vector product? Okay, vector product or cross product is a special multiplication between two vectors. When you multiply two vectors using vector product, the result is another vector, not a number. That new vector is perpendicular, 90 degrees, to both original vectors. If you have two vectors A and B, their vector product gives a new vector C that is perfectly perpendicular to both A and B. In normal math, 2 times 3 equals 3 times 2. But in vector product, vector A times vector B equals negative vector B times vector A. This property is called anti-commutative. Vector product is the mathematical engine behind torque, angular momentum, rotation in 3D space, etc. Without vector product, physics and engineering would be stuck in flat 2D thinking. Thank you. Subscribe this channel for more interesting contents.
What is mechanical energy? So, let's start. At first, what is energy? Energy is the ability to do work or cause change. Whenever something moves, heats up, changes shape or position, energy is involved. Mechanical energy is the energy an object has because of its motion or its position. It is the sum of two energies: kinetic energy, energy due to motion; potential energy, energy due to position or shape. Number 1. Kinetic energy, motion energy. If an object is moving, it has kinetic energy. Faster motion, more kinetic energy. Heavier object, more kinetic energy. Example: moving car, flowing river, rolling ball. Number 2. Potential energy, stored energy. If an object is at a height or stretched or compressed, it has potential energy. Types: gravitational potential energy, due to height; elastic potential energy, due to stretching or compression. Example: water stored in a dam, a book on a table, stretched bow.
Do you know, without equilibrium, structures would collapse? But what is equilibrium? So let's check. We know in nature many forces act on objects like gravity, push, pull, friction, tension, and more. When these forces are perfectly balanced, the object is said to be in equilibrium. Equilibrium simply means balance of forces. It's the state of a body when the total force and total torque acting on it are zero. Let's understand with an example. Imagine a book placed on a table. Gravity pulls the book downward, the table pushes upward with equal force. Both forces are equal and opposite, so the net force becomes zero. That's why the book stays at rest. It is in equilibrium. Engineers use equilibrium to design bridges, buildings, and machines. That's the power of balance in physics. Thank you for watching. Please subscribe for more.
Do you know what is conservative and non-conservative force? Conservative force is a force that stores energy and gives it back completely, and its work depends only on where something starts and ends. Example: gravity. Gravity pulls the ball down. When you lift the ball up, you give it energy. When it comes down, gravity gives that energy back. It's like gravity is very honest. It never steals energy. But a non-conservative force is a force in which the work done depends on the path taken, and energy is not fully recovered. That means the longer the path, the more work is done. Some energy is usually lost, mostly as heat or sound. If an object returns to the same starting point, the total work done is not zero. Some examples of non-conservative force are frictional force, air resistance, viscous force, etc. Thank you. Please subscribe this channel.
Work energy theorem. The work energy theorem is a fundamental principle in physics that establishes a direct relationship between the work done on an object and its change in kinetic energy. It effectively states that work is the mechanism by which energy is transferred or transformed. The work-energy theorem states that the net work done by all forces acting on a particle is equal to the change in its kinetic energy. Mathematically, the theorem is expressed as net work done is equal to final kinetic energy minus initial kinetic energy. This theorem is incredibly useful because it allows us to solve complex motion problems without needing to know the details of acceleration or time. Thank you. Strain. Strain is the ratio of change in dimension of a body to its original dimension when a force is applied. Strain measures how much a body deforms compared to its original size. Strain is equal to change in configuration upon original configuration. It has no dimensions. Strain has no unit because it is a ratio of same physical quantities. There are three types of strain: longitudinal strain, shear strain, and volumetric strain. Strain is directly proportional to stress through Hooke's law. Strain is important because it helps in designing buildings, bridges, machines. Thank you. Stress. In physics, stress is the internal restoring force acting per unit area of a deformable body. In same force but smaller area is more stress. Its SI unit is Pascal, or Newton per meter square. Its dimensional formula is m1L-1 T-2. There are mainly three types of stress: longitudinal stress, shear stress, and bulk stress. We study stress to understand the strength and behavior of materials so that we can design safe and stable structures. Thank you. Young's modulus. Young's modulus is the ratio of stress to strain within elastic limit. It is a measure of how stiff or rigid a material is. It tells us how much a material stretches or compresses when a force is applied. Young's modulus is equal to force times original length by area times change in length of a material. Young's modulus of iron is 21 times 10 to the 10th Pascal. It means that when a stress of 21 times 10 to the 10th Pascal is applied to iron, it produces a strain of 1, that is, change in length is equal to the original length in elastic limit. Its unit is Pascal, or Newton per meter square. Engineers use this Young's modulus concept to choose strong materials like steel or concrete. Thank you.